When we say 2 times 3, quickly we can tell that the answer is equal to 6. But what if we say 2 over 3 times 3 over 4? What then will the answer be? The first is just multiplication of whole numbers. The second is multiplication of fractions. As the first one turned out to be easy, what do you say about the second case? That takes us to the seventh lesson objective of this presentation. It is multiplication of fractions. Please cooperate with me as I develop this section. In this section, we learn multiplication of fractions. It is still under arithmetic of fractions. Under arithmetic of fractions, we learn addition, subtraction, multiplication, and division of fractions. Before now, we learned addition and subtraction of fractions. In this section, we learn how to multiply fractions. You might ask, do fractions also multiply? Granted, whole numbers multiply. But what about fractions? How can they multiply? Please permit me to use this number operation to explain how fractions multiply. At the end of the exercise, we learn how to multiply fractions, whether the fractions taking part in the process have the same denominator or different denominators, and whether all the numbers taking part in the multiplication are all fractions or fractions and whole numbers alike. Please again permit me to use this to explain how to multiply fractions and to prove that fractions actually multiply. It says 2 over 7 plus 2 over 7 plus 2 over 7. Please notice that 2 over 7 is being added to itself repeatedly. What do you call the process of getting a number added to itself repeatedly? From what we learned earlier, the name is multiplication. A number multiplies when that number keeps increasing by the same quantity, the same number each time. Just imagine 2 over 7 increases by the same 2 over 7 and further increases by the same 2 over 7. This pattern of increase is what we refer to as multiplication. That is, repeated addition is what we refer to as multiplication. But first, before I use the sign to replace these two signs, let me use the method we have been taught earlier, the method we have learned earlier to get an answer to this number operation. Please look out as I offer an answer to 2 over 7 plus 2 over 7 plus 2 over 7. And here it comes. 2 over 7 plus 2 over 7 plus 2 over 7 based on this law is equal to 2 plus 2 plus 2 all over 7. I hope you remember this law, the law of adding and subtracting fractions that possess the same denominator. So in the end, 2 plus 2 plus 2 is equal to 6. Now, in the end, 7 is the common denominator. So the answer to this number operation is 6 over 7. Now, keep watching as I rewrite this number operation differently. And now, this number operation has been written in this form. 2 over 7 plus 2 over 7 plus 2 over 7 is the same thing as saying 2 over 7 times 3. That is, bring 2 over 3 into 3 times. I hope you know that this statement is just correct. So this symbol represents a repeated addition. Instead of writing plus plus, plus into the number of times it appears. We just use this symbol. I believe you remember the time that concept was discussed. Now, just bear it in mind that this number operation is summarized like this. 3 is a whole number, and so here we look at 2 over 7 as multiplying a whole number. But we can also rewrite this 3 to take the structure of a fraction. It might not turn to be a fraction, but it takes the structure of a fraction. How do I make this 3 take the structure of a fraction without changing its value? It is by adding 1 as its divisor, so that what we have is 2 over 7 times 3 over 1. See it here. The implication is that 2 over 7 plus 2 over 7 plus 2 over 7 is equal to 6 over 7. The same 2 over 7 plus 2 over 7 plus 2 over 7 will give us this as the answer. It means that the same number operation in 2 different times produced 2 different results. It is not possible for the same number operation to yield different answers. The implication, therefore, is that 6 over 7 and 2 over 7 times 3 over 1 are the same. They have the same value, but they are written in different forms. Because of that, I will just equate this to this, or this to this. Please follow me as I equate this result to this result, since both come from the same number operation. Please watch out. And here comes the equation. That is, this is equal to this. That is 2 over 7 times 3 over 1 is equal to 6 over 7. Now, to get to know the formula for multiplying 2 or more fractions, we make deductions from this conclusion. 2 over 7 times 3 over 1 is equal to 6 over 7. Let us observe things that will help us make conclusion, and that conclusion becomes the formula for multiplying fractions. Please follow through. Now watch the observation. This 6 here could have come from saying 2 times 3. That is, 6 is equal to 2 times 3, which means numerators multiplied to produce 6. What about this 7? It could have come from saying 7 times 1. That is why I said that 7 is equal to 7 times 1. The implication too is that this 7, which is denominator of 6 over 7, came when 7 and 1, which are the denominators of these fractions, when they multiply, this 7 became the result. If you carry out more and more number operations as experiment, you will discover that this conclusion is always the same. Whether you carry out this number operation, numerical experiment with fractions that possess the same denominator or different denominators, you will see that this conclusion is not out of place. Therefore, permit me to make a conclusion with just this single observation, while I charge you or encourage you to pick other examples of numerical experiments, so that at the end, you will now find out if you have to agree with this conclusion or not. But because I have done that before, I'm quite sure that fractions are multiplied in this way. In what way? Please notice how I write the conclusion as to how to multiply fractions, whether by multiplying 2 or more fractions, the same or different denominators. Please watch out. And here comes the law of multiplying fractions. For simplicity, we are taking just two fractions multiplying each other, despite the fact that it works whether the fractions involved are 2 or more than 2. Please find it here on the screen. It says A over B times C over D is equal to AC over BD. In words, when we multiply fractions to get the value of the new fraction, which will come as a result, just multiply the numerators. Write it as the numerator of the new fraction formed. Then come back and multiply the denominators and write the result as that for the new fraction, the denominator of the new fraction. Therefore, A times C is the numerator of a new fraction, while B times D is the denominator of a new fraction. So when we multiply these two fractions, this is how the result will be. Let us see some examples of number operations in fractions, multiplying fractions, that will be done in like manner. Please watch out. And here are the examples. The first example, that's number I, is 3 over 4 times 2 over 5. What will be done? In line with this law, we just multiply the numerators and multiply denominators. See it happen here. 3 times 2. See it here. 4 times 5. See it. Now next, 3 times 2 is 6. And 4 times 5 is 20. So the result of this multiplication is 6 over 20. This is the answer, but it can be broken down to simplest form. How? Let a common factor, possibly the highest common factor, divide the 6 and 20. The highest common factor here will still become 2. So when 2 divides this 6, the result is 3. And when 2 divides 20, the result is 10. Therefore, ultimately, this number operation produced this result of 3 over 10. I hope you followed what happened there. Let us see other similar cases. The next example contains 3 fractions. This was chosen to push home the important fact that when we multiply fractions, the number of fractions is not restricted to 2 fractions. We can have more than 2 fractions multiplying themselves. Let's see example 2, that is number II. 1 over 3 times 2 over 5 times 3 over 8. How do we do it? Simply as before, we just multiply the numerators to get the numerator of the answer. Let that happen, please. 1 times 2 times 3, see it here. 1 times 2 times 3. Whatever the thing turns out to be becomes the numerator of the answer we're going to get. Then, next, we multiply the denominators of the fractions taking part in the number operation. And the result we get is going to be that corresponding to the answer we get. So we have 3 times 5 times 8. See it happen here. 3 times 5 times 8. It is now time to offer answers to the multiplications of numerators and denominators. 1 times 2 is 2. 2 times 3 is 6. 3 times 5 is 15. 15 times 8 is 120. Therefore, the result of this number operation is equal to 6 over 120. This also can be broken further so that it turns to be in its lowest term. How? We divide 6 and 120 by their highest common factor, preferably. That highest common factor is 6. When 6 divides itself, which is 6, the answer is 1. And when 6 divides 120, it is not 10. Please let that correction be done. And here it comes. instead of 1 over 10, the result is supposed to be 1 over 20. Thank you. Therefore, the result of this number operation is 1 over 20. Let us see yet another case that contains more than 3 fractions in a number operation of multiplication. Right. 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. One important fact here again is that the fraction is multiplying itself a number of times. That this is happening does not make the law of multiplication of fractions invalid. We are just seeing different situations and challenges, variations of problems. No matter how many of them, that law of multiplication remains valid. Therefore, here, to get this done, we multiply the numerators to form the numerator of the answer. We come back to multiply denominators to form the denominator of the answer. That takes us to 2 times 2 times 2 times 2, see it. And then we have 3 times 3 times 3 times 3, see it here. The result, therefore, will be 16 over 81. Why? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. See it here. Then next, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Therefore, the result of this number operation is this. Now, watch out for an exercise. And here comes the checkpoint. It says, evaluate the following number operations using a lot of multiplying fractions. Number 1, 2 over 3 times 4 over 7. Number 2, 1 over 9 times 2 over 3. Number 3, 2 over 9 times 1 over 2 times 3 over 4. Number 4, that's the last one, is 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2.